Today, I want to ask you a question. When you open a website, how does your browser actually know this website is real and not some fake disguised by a scammer? For example, you open a bank website, enter your password, enter your bank card, even enter a verification code. But the question is, why should your computer believe that the server on the other side of the screen is really that bank? Even stranger, your browser never seems to hesitate. It sees that little green lock, sees HTTPS, and then immediately starts sending passwords, cookies, identity information, as if it already knew this website. But the reality is, your browser actually doesn't know it at all. Today, let's talk about why your browser automatically trusts hundreds of unfamiliar companies you've never heard of, and the entire modern internet is actually built on top of this kind of trust. First, look at the simplest scenario. You open google.com. Did you notice this HTTPS? The biggest difference between it and the old HTTP is encryption. That is, the data between you and the website will no longer be transmitted in plain text over the network. Others cannot easily snoop on your passwords, login information, bank data, and cookies. Sounds safe, right? But there's actually a bigger problem here. Many people think the core of HTTPS is encryption. Actually, it's not. The most important problem with HTTPS is actually who exactly are you communicating with? Because encryption by itself is meaningless. If you're having an encrypted chat with a scammer, then you're just sending your password to the scammer more safely. So what the browser really needs to solve is, how do I know that the server on the other side is really Google? So the website will send something to the browser called a certificate. This certificate is kind of like the website's ID card. It contains website domain name, public key, validity period, issuing authority. After the browser receives it, it starts checking. But the problem is, anyone can generate a fake certificate. I can even generate a fake certificate for google.com right now. So why does the browser believe this certificate is real? The answer is CA, Certificate Authority. You can think of it as an internet notary office. These organizations are responsible for proving this website really belongs to the company it claims to be. For example, DigiCert, GlobalSci, Sectigo, etc. These companies issue certificates. Then the browser checks, is this certificate issued by a CA that I trust? If yes, the browser shows that little green lock. Sounds pretty reasonable. But the really strange part starts now. Because why does your browser trust these CAS? The answer is because they were already pre-installed into your computer. Yes, your operating system, your browser, they actually have a whole built-in root certificate store. Inside the store, by default, it trusts dozens or even hundreds of organizations. And most people have never heard of these companies in their entire lives. But your browser trusts them unconditionally every single day. You can even open it and see for yourself. If it's a Windows system, go to sutmgr.msc. If it's a Mac system, go to Keychain Access. Chrome, Firefox, Edge browsers also have their own certificate trust lists. You will see a lot of unfamiliar names appear. And the entire internet security system is built on top of these organizations. Actually, the browser does not directly check the root CA. Most website certificates are issued through an intermediate CA. The whole chain is website certificate to intermediate CA certificate to root CA certificate. The browser only unconditionally trusts the root CA. The intermediate CA is guaranteed by the root CA's signature. As long as the chain is complete and all valid, the browser trusts the website. This is the certificate chain. Now here's the problem. What if something goes wrong with one of these CAS? For example, hacked, issuing a certificate by mistake, internal leak, or a certificate is forged. Then what will happen? The answer is very serious. Because in theory, if someone gets a trusted fake certificate, they can impersonate Google, your bank, any HTTPS website, and your browser might not even warn you. This kind of thing has actually really happened. For example, the DigiNotar incident in 2011. The attacker successfully issued a fake certificate for the Google domain used for large-scale man-in-the-middle attacks. After the incident was exposed, DigiNotar was completely removed from trust by all browsers and operating systems and eventually went bankrupt. Similar incidents happened with Komodo, Startcom, etc. So if a certificate is forged or its private key is leaked, how does the browser know to reject it? This is the certificate revocation mechanism. The CA periodically publishes a blacklist, that is, a certificate revocation list, and the browser queries the CA in real time via the online certificate status protocol. Is the certificate valid right now? But CRL and OCSP also have drawbacks, such as being slow, poor privacy, and the CA could be blocked. Modern browsers are gradually adopting more aggressive approaches, such as Firefox's OneCRL or Chrome's CRL set. CAS do not just issue certificates to anyone. There are 3 levels of validation. Domain validation only verifies that you control the domain name, for example, replying to an email or adding a DNS record. Fastest and cheapest, but only guarantees the domain is yours, not the identity of the company. Organization validation. The CA verifies that the company actually exists, and the certificate shows the organization name. Extended validation, stricter checks. the address bar used to show a green company name. Most browsers no longer highlight this. Banks and payment websites generally use organization validation or extended validation. HTTPS is not absolutely secure. In essence, it is a global trust system built on a huge system jointly maintained by mathematics, cryptography, operating systems, browsers, CAs, and the trust chain. If any link in the trust chain has a problem, the whole system will be affected. But even so, the modern internet still has to rely on it because you have to trust someone, otherwise HTTPS simply cannot run. Today's internet is actually built on a very strange reality. Your browser, every single day, trusts a large number of unfamiliar organizations you've never heard of, and you have almost no awareness of this. And your browser, every single day, makes the decision for you who should be trusted. The question is, do you really know who exactly is it trusting?